Hey, welcome back. This is Math, Chapter 5, Lesson 4. How are integers and absolute value used in real-world situations? What will we learn today? To use bar notation, to find a repeating pattern in a decimal, vocabulary, terminating decimal, repeating decimal, bar notation, and rational number. Key concept, rational numbers. Rational numbers can be written as fractions. A over B, the numerator over the denominator, where A and B are integers, and B does not equal 0. In fractions, it's against the law to have a denominator of 0. So these are rational numbers out in the white. All of the ones inside the box are rational numbers. These are rational numbers. This is a decimal. This is an integer. And these are whole numbers. So fractions, positive and negative integers, whole numbers, and decimals. Those are all rational numbers. Write 5/12 as a decimal. 5 divided by 12, we need to annex some zeros. 5 divided by 12 is 0.4166. You see multiplying around the corner. You can see that this 8 repeats. They've got an 8, another 8, another 8. So the third time they got the repeat, they stopped. The remainder will never be 0. So 5 over 12, or 5 divided by 12, equals 0 and 4,166 ten-thousandths, or 416 thousandths, with a bar over the 6. This is bar notation. That little straight line above the 6 tells the reader that that 6 is going to keep going forever. Here's another example. Write 1/9 as a decimal. You need to put 1 inside the bracket. 9 goes outside the bracket. You're going to need to annex some zeros. Show me all of your work on your notebook. Pause while you're working. Press play when you're ready to continue. Number 2, write -2/9 as a decimal. 2 divided by 9, they annex the zeros. 2 times 9 is 18, subtracting we get 2. 2 times 9 is 18, subtracting we get 2. 2 times 9 is 18, subtracting we get 2. So we can see that this is repeating over and over and over. It's repeating, okay? That's a repeating decimal. The remainder will never be a 0. So -2/9 equals -222 thousandths, or 0 and 2/10 with a notation bar. Bar notation, saying that that 2 repeats itself. Write 11/12 as a decimal. Why don't you use a calculator for this one? See how it goes. Show your work in your math notebook. Press play when you're ready to go on. Number 3, write -2 and 2/3 as a decimal. -2 and 2/3 can be written as -8/3. So they've changed it to an improper fraction. 3 times 2 is 6, plus 2 is 8. Same stays the same. So we have a negative integer. It's still negative, but now we're calling it 8 divided by 3 instead of the mixed number 2 and 2/3. These two are exactly the same size. Now we do 8 divided by 3 to get our decimal. The mixed number -2 and 2/3 can be written as -2 and 6/10 with a bar over the 6, telling the reader that that 6 repeats forever. Here's one for you. Write -4 and 5/6 as a decimal. Show your work in your notebook, pause while you're working, press play when you're ready to go on. Number 4, Frankie made 34 out of 44 free throws this season. To the nearest thousandth, what is his free throw average? Using a calculator, divide 34 by 44. 34 divided by 44, enter. They're showing you how to use the calculator, use tools efficiently. And we get 0.77272727. Notice that it's not one digit repeating here, but 2. To the nearest thousandth. Here's our tenths, hundredths, thousandths. So we look at the digit next to the thousandths place. That 7 says round up. So they rounded up to 0 and 773 thousandths. Anna made 15 strikes out of 55 balls rolled during a bowling contest. To the nearest thousandth, what is her strike average in the contest? Go ahead and use a calculator for this one also. 15 over 55. You could simplify before you do your division. Show all your work in your notebook. Pause while you're working. Press play when you're ready to go on. How did what you learned today help you answer the essential question? How are integers and absolute value used in real-world situations? That's all for now.